Hello everyone, and today we are going to talk about very interesting topic, and that is accessing the port pins of any microcontroller, whether NEC or Motorola or NXP. Now it's NXP or microchip or Holtec or whatever. There are tons of different microcontrollers. So I will tell you for first of all, why do we need to use this intelligent and highly efficient, effective way for accessing pin ports? Let me briefly give you an example. What is the meaning of pinpoints? For example, this microcontroller is made by microchip, okay, and it has like 40 pins, like very large number of pins. Every pin can be used to, for example, to send data or receive data and address hardware, external. Whatever inside this microcontroller is called internal. Whatever goes outside is called external. For example, those are called sensor switches or external switches, right? This is another analog sensor, those are input output ports, for example, right? So there are, for example, here audio output. This produce sound, okay? So there are many different things you can do with this. So accessing means we want to send and receive data via this pin. Since it has so many pins, we cannot remember each pin what it does. But what we can do, we can be intelligent, we can be smart and invent by means of software or coding in C language in this case, by inventing a way to make it very intelligent and very easy and very smart and very fast to address any of those pins. For example, this pin is used to send receive data that addresses camera number 1 in security. This pin, for example, address sensor 1. This pin address front door. This is back door. There is no way as a programmer and hardware designer to remember what's the function of this microcontroller. It's impossible. Okay, for that I am going to present this method of accessing pins in very smart and intelligent way. So as a software programmer like myself, and as a hardware designer as myself, as embedded designer as myself, you don't have to spend years and years trying to pull up your hair, find out where the problem in the code is coming from. Okay, so I will give you, for example, a sample code. Here, sample code. I have had this for a long time ago, and since I haven't found anyone on YouTube, or not even not even in the technical support of companies, explaining it the way I'm explaining it, I will leave this code for you guys at the comment here on YouTube. So dive in if you want, and you can use the code block. Use code block. I'm using version 17.12. Use code block to demonstrate how intelligent this code is. Okay, although it may sound, it's like pressing the pedal of accelerator pedal of your car, right? So when you press, you speed up your car, you accelerate the car. It's very simple, but what's going under the hood is very complex. And here, the same thing. What is going under the hood, this hood of the software, okay? I will make complexity turn into simplicity for you guys, okay? So you don't have to pull out your hair while dealing with those kind of things. Okay, here is what I have done, and I thought, Firas, let's be nice with people, programmers, hardware designers, and software programmers. Let me be kind, Firas, and help them understand how this simple thing, yet it may seem or look complex. I will make it very simple for you. This is for software designers, hardware designers, and programmers in general. Okay, it could be in C, assembly, or C++, or even Java, but I am more focused into the like assembly and C. So accessing port pins via data associated to the port. Okay, what is the port? Let me take you here actually to let me take you, for example, You see, this thing here is used. I'm using this for wireless transmitting and receiving. So, for example, we have here. Let me show you. We have something called RB0, RB3, RE9, RB2. Okay, if you notice that like RB1, RB4, RJ3, RJ2, those are all called uh, port pins or GPIOs, general purpose input output. For example, this one here, RB0. Okay, many microcontrollers are known to accept interrupt from outside external outside. RB3, for example, RB5 and RB6, 7, whatever, they are used to send in and out data from outside world to inside of microcontroller and from inside to outside. It's like bidirectional communication. So every pin of those pins is called general purpose input output or dedicated function pin, right? So every pin here has different function. RB0, RB1, RB2, 3, 4, then RA1, 0, 1, 2, then RC0, RC, and so on. And of course, they can be multiplexed around different functions. It's not only general purpose input output, but they can be, for example, communication protocol enhancement peripherals, right? It can be, for example, interrupt that can sense interrupt from timers or external world, like switches. Like, for example, you press one of those sensor switches that's connected to one of those pins, and it tells those sensor switches when you press, it tells, say it's connected to this pin, it tells this big guy, hey big guy, stop doing whatever you are doing, follow my order, do A, B, C, D, and go back to where you came from, continue work. Okay, so those kind of interactions or bidirectional communications between sensors, the world, microphones, and radio connectors, and communication connectors and whatever, right? They interact with those giants, like I call them miniature giants. Okay, they are very small, maybe like this one is 1.5 inch in length, right? But it has like, it's like amazing city inside, transistors, passives, active, many different things. Anyway, so now you have an idea what is GPIO, for example, like RD0, RB0. Those are called general purpose input output. And the ports. What is the port? The port, my friends, for example, let's go to this one here. As you see, this is called, from microchip, microcontroller, or microprocessor. We call it little brain, right? Like a battery operated brain. It's called PIC24. Let's call it just PIC24 family. Okay, let's forget about this. Let's make it very simple for you guys. If you notice that pin number 1, let me do like that. Okay, pin number 1 is this one, near to this notch. Okay, so you see pin 1, 2, 3, 4, 11, 12, blah blah blah, 22, 23, 33, 34, goes to 44. Okay, so, and pin number 1 is called RP9. Okay, let's say, for example, let's say pin number 8 is RB0. All right, let's go down a little bit. Okay, here we go. Say, for example, pin number 21 is called RB0, 22 RB1. So if you notice that you have RB0, RB1, RB2, RB3, and so on, right? It's kind of hard actually to show everything for you very quick, right? Because you have to look for those pins, and that's why I will show you this fast code software which I made in C to help you access those ports and those pins very fast. Okay, for example, here you see, let me go, this is for you, for beginners, but not for me. For beginners, this is a little bit complex, so I will show you different one. This is good for starters. Okay, so this microcontroller has 14 pins. Okay, this is the notch. marking pin number 1. As you notice, you have RA01, RA2, then RA3, RA4, RA5. There is no RA6 because ports in every like different microcontrollers have different arrangements and have different data sheet descriptions, that describe the functionality of those pins. For example, you can say port A engulfing or packaging inside it A0, A1, A2, A3, A4, or A5. There is no A6. So port A has 6 pins. Why 6 pins? Because RA0 counts as 1. So from 0 to 5 means 6 pins. So this specific microcontroller, PIC161503, has port A. Port A is made up of 6 pins or 6 GPIOs, 6 general purpose input output pins, right? It has another port called port C, RC0, RC1, C2, C3, C4, C5. Okay, there is no C6, there is no RC. So it has 7 pins for for port C. So it has 2 ports, port A and port C. Port A has 6 pins and port C has 6 pins as well. Okay, so that's to make it simple for you guys. Okay, now let's go back to the meat, the beef. Okay, remember we are talking about how we can easily access those pins: camera 1, camera 2, front door, back door sensor. For example, this one to start your car, this is to start your drone, this one, for example, to monitor your baby sleeping in his room or her room, whatever, right? So like 44 pins or whatever, right? So I am using a very smart way, although some engineers are like definitely are aware of it, but maybe they don't share it with you, so I want to share it with you today. Okay, let me show you here the trick. If I click on this this bracket, okay, you find that I'm using something called union, and it ends in here. It starts from here and it ends in here. Union actually has like a memory size or data size equal to the largest size of its members. Okay, and the largest size of its members is this one here, port value. I'm not gonna explain to you what is union. I'm assuming that you have basic understanding of union, because talking about union takes like some time, right? So this is not the purpose to explain to you what is union, how does it work. I'm just telling you where you use union, why you use it, and how you use it, because it has thousands and thousands of different applications. So in this specific application is which is called an easy access and intelligent way of accessing those pins via software by humane way, not machine way, is this way. So first we have to create something called union. Within the union we have to create a structure. So you see this structure? So you have union engulfing inside it, hugging inside it, a structure. So if I click on this structure bracket, you see that it ends here. In the structure, this is now the beef. I will give you the beef. In the structure, I'm using pin for alarm 3. In this structure for alarm 5. For camera in the front door. Camera in the back door. Sensor 2, then X-ray imaging sensor to see what is going on around the area. Okay, we are monitoring. Okay, for example, this could be alarm 5, alarm 3, this is X-ray, this is sensor 1, sensor 2, backyard camera, front door camera, and so on, right? So, and as I said, it's really not easy to remember which pin is which, right? So this one here, this software by using what's called Union and Structures. Union, this is the new Union, this Union here, Union and Structure. In this specific arrangement, please don't change what I'm giving you. I will give you this code for free in the comment of in the video below. If you follow this my advice, my recommendation, this will make your life very easy. Say for example, let me go back to the wireless device. Okay, if say for example, this is my wireless device, right? I received, say for example, from RB1, I received a wireless data that's coming from the Wi-Fi or Zigbee or coming from Bluetooth low energy or whatever, right? It has a data. Though this data enters as streams of zeros and ones into the microcontroller. Okay, now inside the microcontroller, let's go back to inside the microcontroller. This packet, which is read through like RB0 or RB1, whatever, I just show you, it is decomposed. It is taken from the wireless input port as port value, and then this specific structure, which is called union engulfing structure, or which we can call it structure within a union. So this structure within a union methodology will help you guys decompose the data that arrive to your wireless device, and it will tell you that do this to alarm 3, do this to alarm 5, do this to camera, front camera, do that to back camera, do that to this to sensor 2, do whatever to the X-ray and whatever, right? So you don't have to pull your hair and decompose the data packet which you received from the air. You don't even see it, right? But it goes inside your wireless device. You just read it and put it here. So this becomes input. Okay. Now you cannot read the packet because it has zeros and one. You don't know what the hell going on inside this packet. But this unique structure, which I call it structure inside union, has the intelligence to know what is going on inside this packet. It will does the magic for you. And believe me, guys, I was working in Florida in one of the big companies, fire and security. They assigned me a security project. The engineers who were working on the same project, which I completed successfully, it took them more than 5 years to do just to start with it. They didn't even finish it. I took over those full team of engineers, all by myself. I swear to God, only by myself. I did the whole project. I finished it in 9 months only, not 5 years, in 9 months. And they are a team of engineers. I think there were maybe 3 engineers and a couple of mechanical engineers. Of course, I had a mechanical engineer helping with me because plastic is not my specialty. My specialty is embedded design. So bottom line, because I know how to organize my software, I know how to organize my data, I know how to write smart code, easy to read, easy to debug, easy to see what because sometimes codes can go up to 10,000 lines. Like I've written many times. I've written codes that go like near 5,000 plus lines. You know. So let's go back again. So once again, let me go back again. Once this hardware, this is connector actually. We gave, say for example, we gave the input from the wireless radio. We gave it the name of RB1. This RB1 reads the data from the air, from the antenna, from the air. It drives it in, and say for example, this data. Let me take you to the other page. This data is automatically by software code is put in here, and then once it is put in here, it automatically it is decomposed into those commands, into those instructions, into those pin numbers, into those useful data that we human, our brain cannot comprehend zeros and ones, cannot comprehend symbols. But I know what is alarm 3. Probably everyone knows what is sensor 2. It means sensor in the second door, for example, right? Camera in the backyard. But we don't know that this is the camera in the backyard. Let this code does the intelligent work for you, okay? Let me give you the advantage of using. You can do it. There are many different ways, but this is one of the most brilliant and intelligent way of doing it. Why? Because this specific arrangement of structure, within the union, okay, first it preserves the packaging. It's well packaged. The data packet is well packaged. Also, it transforms the weird computer machine symbols into a human readable format. Also, it follows the exact order, because if you don't have the order, and you sometimes software engineers don't know what the hell they are doing. They use back camera instead of alarm 3. They use X-ray instead of alarm 5, and they blow up the whole system. Sometimes the whole system smoke because engineers don't know sometimes what the hell they are doing. Believe me, I've seen a lot of engineers blowing a big fire inside the control panels. Why? Because no one taught them. And I want to teach you those kind of methods. So please, after you have completing watching this video, go to the comments, copy it, and paste it into code block. Okay, post it into code block IDE, and try to experiment with, try to play with it. Okay, don't worry, it's not gonna hurt you. It doesn't bite, believe me. Just experiment and play with it, right? So this arrangement is called structure within the union. Once the wireless data dumps the value read from the air in here, this intelligent arrangement will intelligently decompose it and route it to the proper, and it execute it, and it does process it. It chews on it and give you, for example, display. It turns on alarm system, for example. It starts your car. It flies the drone, right? So all of those things, like action and reaction, right? So action, the wireless packet goes inside the microcontroller. The reaction, the drone flies, or the image of person on the front door is captured, for example, right? And so on. The X-ray takes a secret or hidden images of people behind the door or the wall, whatever, right? So here I'm demonstrating. I cannot give you my code, private code, but I can give you an idea about how you can create your own methods of intelligently and smartly and very fast accessing those ports. Okay. So in here, after the data is read wirelessly from the air and dumped here by software, what will happen? Let me run the code. Okay. Remember, this is code blocks. Okay. If you click on this one here, build and run, look what's gonna happen. Here we go. Okay. Accessing the microcontroller GPIO automatically. Okay. So let's say, for example, the data that's read from the air is 27. It was dumped to the port, say port A, or to the packet. Okay, this packet has, or the port has 8 bits, or it could be 16 bits. Sometimes it could be 5 bits. You remember that the microcontroller I show you, it has port A 6 bits, and port C it has 6 bits. Okay, so sometimes the port can even have 2 pins, or GPIOs, general purpose input output, right? It can have 7 or 8 pins. So let's assume that we are dealing or working with microcontroller that choose or process package made of 8 bits, bits from 1 to 8, or it is operating on port B, for example, port B bits 1 to 8, or bits 0 to 7. You remember, if it is 0, if this is 0, then this is 7 for 8 bits. But if this is 1, then for naming convention we call 8. So total of 8 bits. As you see here, the action is taken automatically. This is really very smart, because you don't have to look in the code where the alarm 3 is located, where the alarm 5, where the X-ray different bits are located. Say like X-ray sensor, say it has a transceiver and the receiver and power supply. So the microcontroller actually, through the packet, that data packet, that's what it does. It activates or deactivates certain behavior or it takes images or whatever, certain behaviors within the microcontroller. So in this X-ray, for example, it has 3 pins, bits 0, 1, and 2. The other alarms, cameras, sensors, they have the rest of the bits, right? So by just dumping this port value from the air, it is automatically interpreted and is taken to the code, to the firmware or the code, and it is interpreted intelligently without you as a programmer have to pull your hair and spend years and years trying to develop a code that can take you maybe 6 months or 1 year. It depends on the complexity, of course. So let's close this one here. Okay, so now you got an idea. So here you can dive in, like again, I will leave this code for you in I did here some tricks, so I will leave it for you to read it and understand it. Again, I'm giving you only the beef. I will not teach you how to cook it. Okay, I assume that you don't know how to cook the beef, but I will cook the beef for you. I'll just cut it into pieces and put it in your mouth. You chew on juicy and tasty beef. Okay, so let this cooking be done by me. So enjoy my cooking. I hope you like this stew beef or whatever, right? And enjoy it. Chew on it. Don't swallow it. Okay, just read it carefully. Try to understand it and have fun. Thank you for watching. If you have any question, please leave your comments below. Please, as always, like, subscribe, and share this amazing experience with other engineers, because believe me, engineers nowadays, I know, I have worked in many different companies. Engineers, sometimes they don't know what the hell they are doing. I want to help you guys, right? And sometimes engineers leave a company because of the legacy, terrible legacy of shitty, like very bad software they wrote, right? So now we have to rewrite the whole code, and it's pain in the where. I'll just say pain in the neck. Again, guys, have a great weekend. Thank you so much for watching, and as always, like and subscribe. Bye now.